Hi everyone, we're on page 374 here, text and test 4, populations and sampling in statistics. I'm going to start off by just talking about the difference between a survey and a census when you have a large population or a population that you want to work with. So first of all, the population is who are you trying to survey? So it might be, for example, the entire population of Ireland, but it might also be sixth-year students in St. David's. So you get the population is who you decide to study. If I look at every single sixth-year student in St. David's Secondary School, then what I'm doing is carrying out a census. That's where you survey every member of the population. Whereas a survey, or where you speak with or where you gather data from every member of the population. A survey is, rather than looking at all the sixth-year students in St. David's, maybe I only look at 10 of them. And I hope that the 10 that I pick are a representative sample. And that's going to be an important word in this section, is representative. Is my survey representative of my overall population? So if I'm not taking a census of the entire population, then it's very important that the people I do pick out are a good representation of that population. So for example, if I was discussing attitudes towards PE, and I only spoke to just boys, say, I would get a very different type of answer than if I spoke to half boys and half girls. So that would be the importance of having a representative sample along gender lines. Right, let's have a look back in the textbook, just some of these ideas. A sample survey is what I'm talking about. It's where you've got a large population. Usually it's too big to take a census. So let's say the entire population of Ireland, you might pick 1,000 people. What you want to do is pick them at random. You want to avoid bias in your sampling. Okay, now what you're aiming for is this thing called a simple random sample. That is, every single person, when you take a survey, every single person in the population has an equal chance of being picked. And the simplest way to do this is put everyone's name in a hat and pick them out at random. Okay, types of bias that you can see. You pick a sample which is not representative. For example, if I was only to survey boys in my example of the St. David's attitudes towards PE, not identifying the correct population. Okay, if I was asking what's the attitude towards PE in St. David's, and I only looked at sixth-year students, that wouldn't necessarily represent everyone. And who responds? Okay, if I'm doing a survey about PE in St. David's, and I give you an option whether you respond or not. The people who are most likely to respond are the people who really love PE or the people who really hate PE. So you're going to have a bias in your response just from the way that the responses comes back in. Okay, so your sampling method is quite important. This is what you're aiming for, is the simple random sample, but actually that's a very hard thing to do, is get everyone. If this was everyone in Ireland, you're not going to get every single name in Ireland, put them on a hat, write them on a piece of paper and put them in a hat. That's a very hard thing to do. So other ways to do it, one would be a stratified sample. Okay, so if you want to make sure that you're well represented in terms of ages, you might go to the census data and you'd say, well, I know in Ireland that in this case 45% of people are less than 40 years old. So in my sample, I need to make sure that 45% of my sample are under 40 years old. Okay, and then you'd have between 40 and 60, 40% of my sample needs to be between 40 and 60, because that reflects the fact that 40% of the population in Ireland are between 40 and 60 years old, and so on. Okay, that's just going along age. Other ways you'll often stratify data is by male, female, retired working, nice example, or in education. And you just make sure that your sample is in the same proportion to the population. So that's one way of collecting data in a way that you hope is representative, even though it's not a simple random sample. Another one here is this idea of systematic sampling. Okay, so if you have a list, you would pick every 20th number in the list. An interesting example of that is when you're correcting Leaving Cert exams. Actually, you normally have about 400 exams, and what the State Exams Commission collect off you as you go to see are their marks lining up the way they want them to line up is they'll say pick a paper at random from the first 20, so you say 13, and then they say pick every 20th paper after that, so the 33rd, the 53rd, the 73rd, and they want you to report the grade in that. So that's a systematic sample. Quota sampling is one used by market research companies and stuff where they'll tell an employee to go out and get, 100 responses to a survey. But the problem there is the employee might just go out and ask their friends, or they might ask everyone on one street. They might not have a very good level of randomness about how it comes back. But you do get all of the data that you need, which is an advantage, because sometimes just getting enough responses can be an issue. Cluster sampling is really, really common. If I want to survey 60 students in Ireland, maybe I just go to 6 different schools and I survey just those 6 schools and the 6 students there. And then I assume that those schools are representative of all of the 6th-year students in Ireland. Okay, just a difficulty there. If I went to 6 private schools, well, that wouldn't be representative of all of the schools in Ireland. If I went to 6 all-girls schools, that wouldn't be representative of all of the students in Ireland. And then convenience sampling is one where basically, because people are willing to take part in your survey, so very often internet polls will have some type of convenience sampling where you can just organize a survey quickly and easily, but it's rarely random. And that's really what you're aiming for. So let's look at a few questions here and see how we find them. So question 3 for each of the following methods, state whether it would give us a random sample or whether it's likely to be biased. So take every 10th person from a list, number 2 there, that's going to be random. Put all the names from people that are in your population into a hat and pick without looking, that's going to be random. Testing the first article produced each hour by a machine, yep, it's going to be random. Number all items and then select by using random number tables, or a random number generator on your calculator. That'll be random. The only one here that's maybe not is interviewing everyone in a local supermarket. You're more likely to get, say, homemakers, or if it's during the day, people who aren't working. So you might be excluding people from your survey if you're doing that. Just looking at question 5, what type of sampling is being used in each of these surveys? Kate's doing a survey to find out how often people go to the cinema and how they travel to get there. She stands outside her local cinema and questions 20 people as they go in. That's very much convenience sampling, and it is likely to be biased because she's talking to people who are obviously going to the cinema. People who do not attend the cinema have no chance of being in that survey. Endo wants to know how people's voting intentions as they enter the polling station on election day. He questions every 5th person as they enter the polling station. That's a systematic survey that he's doing there. And as long as Endo is clear that the population he's interested in is people who are voting, then that's a reasonably random way of collecting that. Obviously, people who do not vote are excluded from that survey. There are 60 girls and 40 boys in 5th year. The school principal wants to interview a sample of 20 students, and she randomly selects 12 girls and 8 boys. So that's 60% of her sample. 60% of the 5th year is girls, and 60% of her sample is girls. 40% of 5th year is boys, and 40% of the sample is boys. That is a stratified sample there, stratified along gender lines. Question 11 here. In a school, if there's 460 pupils in junior cycle, 420 in senior cycle, how many pupils from each cycle in the school should be included in a stratified random sample of size 100? So finally, we've got a calculation to do. We've got 460 junior students, 420 senior, which is 880 students in total. Well, 460 out of 880 junior students represents 460. Excuse me, out of 880. Okay, that represents 52 odd percent. So I'm actually just going to say that's 52%. And 420 out of 880 then is the remaining 48%, I guess. Yeah, 48% there. So 48% senior and 52% junior. So in your sample of 100 students, then you'd want 52 out of 100 to be junior students and 48 out of 100 to be senior students. That's stratifying your sample. The question then says, in what circumstances is a stratified random sample taken rather than a simple random sample? So a stratified random sample will be taken where the population, in this case school students, can be easily divided into groups, in this case junior and senior. and you would like to make sure each group is correctly represented in your sample. Okay, so as well as making sure you've got 3, 5, and 11 done in your copybook, can I ask you to write a short note on each of these terms, please? And then, as usual, the list of keywords at the start of the chapter, a very good place to go to finish off. And make sure you know that you can explain as many of these as possible. Okay, see you next time.